The word relative is a general term which can be applied to any physical, non-physical, scalar, or vector quantity. All comparisons between any two quantities are relative in nature. For example, let's say Ram's height is 5 feet and 6 inches, while his wife's height is 5 feet and 4 inches. If I ask you, how tall is Ram relative to his wife? Your answer will be 2 inches. How did you find it? You simply subtracted height of Ram's wife from Ram's height. This simple concept can be applied everywhere, whether you want to find relative velocity, relative acceleration, or anything relative to that matter. Using the same logic, the relative velocity of A with respect to B is written as VAB, and it is equal to velocity of A minus velocity of B. Similarly, relative acceleration of A with respect to B is equal to acceleration of A minus acceleration of B. We can also write VAB equal to minus VBA and AAB equal to minus ABA. Let's solve an example to understand this concept better. Question. Chintu is moving due east with a velocity of 1 meter per second and Mintu is moving due west with a velocity of 2 meter per second. What is the velocity of Chintu with respect to Mintu? Solution. This is a one-dimensional motion problem. We are given that the velocity of Chintu is equal to 1 meter per second in east direction, and velocity of Mintu is equal to 2 meter per second in west direction. Before solving the problem further, let's try to understand another important term, frame of reference. Frame for reference is almost like I am carrying a picture frame around with me and trying to see the entire world through this picture frame. Or in other words, I keep this frame as a reference to see things from my point of view. Now, if I call one of the edges of the frame as y-axis and the other edge as x-axis, the corner where both these edges meet becomes the origin. This is my two-dimensional frame of reference. If nothing else is mentioned, then this frame is assumed to be attached to the earth. In the question, our frame of reference is Mintu. We need to find velocity of Chintu with respect to Mintu, which means that we need to know velocity of Chintu from Mintu's point of view. As discussed earlier, to find velocity of Chintu with respect to Mintu, we must subtract the velocity of Chintu from the velocity of Mintu. Mathematically, we can write VCM equal to VC minus VM. Now putting the value of VC and VM in this equation, we get velocity of Chintu with respect to Mintu, 3 meter per second. This is the design.